Hey everybody, this is your 2.5 calculus video on continuity. So basically we're going to solve problems involving continuity from graphs. Like if it's a jump, then it's not a continuous graph. Applying the continuity test, limits involving trig functions, and continuous extensions. So sometimes there are functions that have outputs that vary regularly and consistently with the inputs and don't jump without taking the values in between. Piecewise sometimes have numbers where the function has breaks. They are continuous if they are from the right and the left. In general, a function is continuous if it can be drawn without lifting the pencil from the paper. Others are discontinuous. So one type of continuity is continuity to point. Be careful about a jump discontinuity similar to the step one, and also removable discontinuity where you can change the function at that one point by creating something that is continuous. There are numbers at which the graph has breaks, but may not be continuous at a point, but it could be from either the left or the right. You can have a limit and a function value that's not the same, so there's a break. The numbers at which the f has no breaks, you could have the same value as the function. You have the limit from the left has a minus, from the right has a plus, and it's continuous if the limit from the left is equal to the right. And it's continuous also if you can actually plug in your c value and f of x is equal to f of c. So a rational function is continuous except where either a whole or an asymptote appears. Exponential, log, sine, and cosine are continuous. Tan, cotan, secant, cosecant are continuous except for where their asymptote is. And sometimes you're going to have to remember or see from the graph whether that happens at pi halves or at pi. So there's your formal definition, which you can read if you'd like, and then also about the formal definition of discontinuity. Your continuity test has three parts. F of c exists where c is in the domain. The limit exists, and f of x equal f of c. And there's different types of discontinuity we've seen so far. You do have some properties of continuous functions where you could add functions and it's going to be higher up on the y values. You also have differences where it could be lower. Constant multiples, products, quotients, powers, and roots. Then you have your intermediate value theorem, which basically means if your two y values have a sign change, then that means you must have a zero of the graph. Okay. So let's jump to the problems because I think those are the most helpful parts. So on this one, there is a hole in the graph at 2, so it's not continuous at 2. Very simple. That's where the bubble was. And now pay attention to your interval because like in this one, they want from -1 to 3. Oh, I guess that's the whole thing. But it's not continuous there at 0, where x equals 0. because of the jump discontinuity. Now the others also said 0, but you need to know this is called a jump. It's not oscillating and it's not removable. Like this one right here would be considered removable, because you can add an extra part and say f of 2 is whatever that is. Now you have a piecewise function with so many parts. It says, does f of 2, negative 2 exist? That means, does the point exist at negative 2? No, because there's no y value, because it's an open circle at x equal negative 2. And then does the limit exist at negative 2? Yes, because the left and right both approach the same number. Both approach 3, basically. Does the limit equal the function value? No, because the function value is undefined. So how could it? And is it continuous? No, because there's a hole in the graph. Okay, now we have something like that with 2 for x, and so there's a solid point, and yes, it's continuous. That's really fast. It just wanted x equal 2 for both of these. It's not true for 1, and it's not true for 0. Here's another one where they give you many pieces where it looks random, but all they're caring about is f of 2, so that would be in the part, well, it's undefined. Well, this piece and this piece actually are connected. This one from the slanted line, this one from the horizontal line, and so that really is going to be 3. If you want to bubble that in, you can bubble it in, since the left and the right connect to 3. Because this was touching that, and so you can bubble it in. So that'll help you know that the ordered pair would be 2, 3. On this one, they want to know where it's continuous. So it would not be continuous at positive 10, because it's like all reals x not 10. If you want to graph this, you can, but that's basically going to be the point of it. So 7 over parentheses x minus 10, and then minus 2x. Now, so far it looks good, but I know we had a denominator that we're interested in. And if we bring this over to like 20 and lower this to like negative 20, it's different. You can imagine this being a vertical asymptote at 10, where this is swooping down and this is coming that way. If it helps you make this like negative 50, then you see it even more clearly. So it's basically all reals x not 10. Now this one, what you would do is factor your denominator. So you have x squared minus 12x plus 35 in your denominator. Now, since we have x plus 5 on top, let's try using that. and then do 35 divided by 5 and we get 7. And sure enough, 7x plus 5x is 12x. Now the problem is these should be minuses though, because I need a negative 12 with a positive 35. So this should actually be a minus right there and a minus right there. So they're not canceling after all. They don't cancel. So it's not a whole. So now we just need to graph it. When we do the algebra with it, or the math, it helps us to know where to look in our graph. We've got x plus 5 over x squared minus 12x plus 35. So there's one thing that was obvious about the 5. So if we go to our table, it's undefined at 5. And so that's this part. But like I said, you can't always see everything. So we might have to adjust our window. I'm going to do menu 4A. When you do that, it helps a lot on that particular problem. Because you can see the graph is going to go like this, and down in between. So we need to find out those two spots. Well, it's 5 and 7. So this at x equals 5, this at x equals 7. So we're continuous to the left of 5, in between 5 and 7, and right of 7. Now all of these had to be parentheses, not brackets. Use parentheses, not brackets, since it's an asymptote. Now here we have a random function, but what we know is absolute value of x by itself is continuous, and sine by itself is also continuous. And so probably the combination is also going to be continuous. So let's graph it. Absolute value 3x minus 7 plus 8 sine 5x. Okay, so that is really weird. It's almost like it's icicles. Now if I do menu 4A, that is awesome. I like that. It's pretty. But it's all real numbers. I'm going to call it icicles, I think. Oh my. Okay, that's all right. Okay, so I did spell that right. It's funny. But yeah, there's the graph. It's pretty nice. Now in this one, you have an absolute value function, which we know that's continuous, and we know x cubed is also continuous. And so probably the v combining with this will also be continuous. So let's graph it to be sure. You do have some unusual functions in calculus. And so that could be useful like in computer engineering or graphing. Okay, there it's backwards, but let's do the menu 4A. Apparently that's parts of the dominant part, the x cubed. Because I do have this part, right? At any rate, that is continuous. There's no problems here. Yeah. Oh, I see it's going a lot lower, but that's fine. So it's approaching negative infinity. Okay, now here they want to know where that function is continuous. And so basically find the asymptote. That would be your instructions. Now it's a bit different because you have a trig divided by a quadratic. Because see, normally tan by itself, make sure you're in radian mode, but tan by itself would have asymptotes at, okay, let me just fill in the blank. Well, it goes through the origin, and so then it must go through pi, so it has asymptotes at pi halves. That's my thought process. Because I know sine and tangent touch the origin, and so you can't have asymptote at the origin. It'd be right there. Now that's for the normal part, but here you have tan 3x, which means you're going to have to do pi over 3 or pi over 6. So let's just graph it and see. Dang. 6x tan 3x, all of that divided by x squared plus 4. Okay, well you can't see it at all. Still can't see it at all. Oh, I bet I know what I did wrong. I bet I have to put times in between. Yeah, and now that I'm zoomed out so far, it's looking really crazy. Yeah. So it's interesting. It looks like a little parabola in the middle, and then it's going like cotan at first, and then like tan. So that's pretty wild. Huh. So what we need to know is where is it undefined? And if you just look in your table, it's not going to help yet. So what we need to do is go to where it's 0 in the table. I want to go to the table settings. I don't know if y'all caught that or not. Let me go back. If this is your active part of the window, then when you do menu, it says 7, and all it says is split screen or remove, which is no good. Okay, that's if that's the active part. What I want is I want the table to be active. So now if I go menu table, it gives me this menu. And I want to do edit table settings, start it at 0 and go by pi 6. Because it's multiple choice, I could check pi 6 or pi 4s. It won't be the -4 or 0. Because that doesn't even really make sense. So pi divide by 6, I see my undefines. 0, pi 6, 2 pi 6, 3 pi 6 is the same as pi halves, and so forth. Now, just for completeness, if you want to, you can go to table settings, and if this were pi 4s instead, then it's all numbers. And if it's numbers, it's continuous. So we do want the pi 6 part with an odd integer. Yeah, you can. Now on this one, it wants to know where it's continuous. The first step would be to set your denominator, you're underneath the square root symbol equal to 0. So x is 3 halves. That's going to be your starting point, and what you know is it's a bracket. What we've said before is if it's a square root or a fourth root, that it includes the number. And it's not going to be like an asymptote or like a hole in the graph or anything. So let's graph it. So we're going to do nth root, and we got to put a 4 here and put 2x minus 3. Okay, so from about right there, 3 halves on, or 1.5 on, it's continuous. So even if I went out to like 100, it's still going, like the Energizer Bunny. Okay, then on this one we want to graph it. (11 minus 10x), raise all that to the 1/3 power, and it looks like that. What I remember is anytime it's like a third root, it's going to go sideways, like kind of like in diagonal quadrants, but it did translate a little bit first, so it's not perfectly like that. Kind of reminds me of if you're running and you have to run through this zone and this zone and this zone, then you earn your 3 zones. And so it is continuous. Catch that Madden reference. Okay, here we do the cosine function. And remember, we never type the limit part. That's just going to be the number we're interested in. We type this part. So you go cosine 8x minus, oh, it's another cosine? That's interesting. Cosine of another 8x. It's almost like nested cosine functions. Okay, so that's like that. Very short. And then we care about where it's 11 pi over 6. Now, I'm not going to try to guess where that is. I wouldn't expect y'all to do that either. But I would go to the table, I'd go to my 0 part, and go to my settings. Oops. And just start your table at 11 pi 6. I don't really care about the step, but I guess just for curiosity, I'm going to go by pi 6. Okay, so a couple of things to talk about here. Now, first off, this is negative pi 6, which is like the negative 0.52. If you go to this one, you'd expect 0, but it says a number, e to the minus 13. So if it's 1.2 e to the minus 13, that means point and a bunch of zeros and a 12. So it's close to 0. May as well just assume it's 0. Okay, so we're going to 11. So there's 0, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I get this. Now, I wonder if I didn't type it right. Let me double check something. Cosine 8x minus cosine 8x. Well, I can see it's continuous, which is this part. The question is, why is this 0? Let's trace. Okay, so what I'm looking at is what my y values are, and it's 0, it's 1, that's close to 1, it's 0, it's negative 1. So apparently, like, these values are pretty close. There's 0. This one's 0.15, but that was at 1.5. What may help is if we go back to this part and do 11 pi divide by 16 as a decimal, it's 2.16 approximately. So if we want to look around 2.16, there's at 2.1, it's negative 0.1, and at 2.16 it is 0. That's very convenient. So that'd be my recommended approach. So use graph trace, use graph and trace after you figure out what the decimal is, and then you can see it's about 2.16 comma 0, because there's your stuff with 0. So that literally means the limit would be 0 because that's the y value, because the limit is y. And we already said it was continuous. Now on this one, define g of 5 so that it is continuous. Now when I see the format of the problem, I see a quadratic in the numerator, I see a linear in the denominator, and so it probably has a hole. In fact, if I graph it, I bet it's going to be slanted. Not like a parabola. So let's do that. $7x squared minus 175 divide by 7x minus 35. Okay, see, it is slanted. So remember, if it's quadratic on top and linear on bottom, that it's going to have a hole. Now the hole's not going to be visible if you do menu 4A. It still looks continuous. So this is where you can't just rely on your graph. Let me pause this for a second. Okay, so what I was saying was, this is where in your graph it doesn't look like it could be a hole, it looks continuous. But if we set our denominator equal to 0, set denominator equal to 0, we have 7x minus 35 equals 0, and so x is 5. That's where it's undefined. So if I go to my table, Control T for the table, at 5 it's undefined. So what we're going to have to do is figure out where to plug the hole, kind of like think of water rushing through the hole. Well, what we know is in our table at 4 it's 9, at 5 it's undefined, and at 6 it's 11. So you need to do the midpoint, and it's 10. I mean, on something like this you can just use common sense. This one's 9, this is 11, so 10 is in between, 9, 10, 11. So then 10 would be your answer. So if you define g of 5 to be 10, then it would be continuous. We're going to do the same idea on this one, having to do with 8. So one thing I just want to try real quick is, what is 512 divided by 64? It's 8. That might actually be a big hint. Now, when I do my denominator part, I'm going to factor this into s plus 8, s minus 8. And you see I just used my numbers there with 5, 12, and 8. What I'm going to do now is I'm going to say, well, I wonder if what's going to cancel is going to be the s minus 8 or the s plus 8. How I would know is it's a cube that has minus, and so if I'm just guessing and checking, the minus 8s are going to cancel. Now, I don't know the rest of it without doing long division. S cubed plus 0s squared plus 0s minus 512. And then let's do s minus 8. Now, if I do this correctly, we should get a 0 remainder. So we need s squared here. Remember when you're doing long division that it's implied subtraction, so this cancels. And this would be 0 minus a negative 8. That could be a common mistake right there, so be careful. And then I bring down my 0s. And so then this to this, think about 8s squared divided by s is 8s. So this is your 8s squared minus 64s. And again, subtract, cancel. Minus a negative 64 is positive. Bring down your 512. And then from here to here is 64 for what I need. 64s minus I bet it is 512. Well, yeah, 64 times 8 is 512. So sure enough, we did get a 0 remainder, which means we have a winner. We go s squared plus 8s plus 64. Okay, so with all that, that's the new factoring of it. What we need is, like, what do we need the definition of f of 8 to be? So let's try looking in our table at what happened at 7, 8, which was undefined, and at 9. So, do we have that graphed now? No. X to the third power minus 512 divided by x to the second power minus 64. So it doesn't look like anything's happening, but that's just because it's higher up. And what we can see is at 7, it's like 11 something. It's 11.26 repeat. And at 9, it's 12.76. Now, I don't just want to guess 12, even though I see that's the answer. What I would do is, if I know this cancels, I'd plug in 8 to this, so it's 8 squared plus 8 times 8 plus 64, and then 8 plus 8, so that's 16 on bottom. Okay, so let's see what we have. 8 squared plus 8 squared plus 64 is 192. And 192 divided by 16 is 12. So this long division really did help, because now I can guarantee that it would work. Because here I'm just like guessing, and I don't like guessing, but here the math worked. And it's 12. Okay, just two more. This one, it's more of a description or paragraph. It says a continuous function is shown to be negative at x equal 1 and positive at x equal 3. Why does it have a solution? Well, when you're changing sign for your y value, that means that there would be an x-intercept. Between, in this case, 1 and 3. Now when we look at our multiple choice, it says there's at least one solution between 1 and 3 because it's continuous on 1 to 3. And if you have a sign change, well, if y0 is any value between there, then it's equal. So that's going to be kind of like a definition that you'll need to remember. But basically the graph looks like this, that you need to choose where it's down and then up. So it's negative at x equal 1, and it's positive at x equal 3. And so it fits the definition for it being a sign change, so there's an x-intercept. Okay, last one. This one, they just want you to use your calculator in radian mode. What I bet we're going to have to do is say F1 is cosine and F2 is x. And then get the intersection. So again, make sure you're in radian mode. Trig, cosine, x, and then F2 is going to be x. There's where it crosses, and you go menu 6 for between here and here is your 0.73908. 0.73908. They want you to round to 4 decimal places, and so based on this 8, we have to round up. So it's 7391. Okay, that's the end of that video. Hope that helps.